Chirag Singh, who, as you can see, is already so excited to share that he already has his screen shared and his video turned on already, ready for all of you. All right, so thank you all for being here and respecting our speaker for being on time. And without further ado, I will now pass the floor on to our lovely speaker, Chirag. Chirag Singh, you can now take it away.
So hi everyone. Hope you are able to see my screen. And yeah, so welcome to Kafka workflow automation by using Ethereum framework. So in next 30 seconds and 30 minutes, I'm going to show you how you can validate Kafka workflow automation, how you can validate Kafka event validation by using Ethereum. So my name is Chirag Singh and I have around 10 years of experience software testing. So let me start. So today agenda. So today we will discuss what is Ethereum and what is event-driven architecture. Then we will see what is Kafka and how to set up this framework. And then we see how to do the Kafka event message validation with this framework. Then I will show you the demo. So I will execute the test script in front of you, and we will discuss how the things will configure in this framework. So let me start with another slide. So before going ahead, let me discuss what is Ethereum. So Ethereum is a low-code test automation framework developed by using Java and Cucumber. And this framework supports BDD. And the main part is in this framework, you need to just create a simple Excel file. You do not need to write much code. You create your test steps, test script in a simple Excel. A complete end-to-end workflow. I should say a complete end-to-end workflow in Excel, and then you just execute the framework. Then it will create the feature files for you, and it will just create it a report to you. So as an end user, you just need to create Excel and run this, and all the magic will be done by this framework. So tester can be created quickly, tested in minutes. Yes, because we do not write much code. We just write our workflow in Excel, and then all the things will be done. And it generates a beautiful report which supports a BDD Cucumber style. As it supports a BDD, so it gives a report a Cucumber style. It provides complete testing for REST API, Kafka, GraphQL, Kafka event message, and DB. So by using this framework, you can do this type of testing. And as a tester, you need to just create a Excel sheet with appropriate columns and pass your data to this framework, which is Ethereum. So let me move to another slide. So now we will discuss what is a microservice and what is a event-driven architecture. So event-driven architecture, why it is important? So let's see. At the left side, you can see there are multiple of microservice are available. So at this green microservice is exposed by exports itself to another microservice, and same time it is publish a event to a event backbone. So for example, event backbone is Kafka. So here it is publishing a event to a Kafka, and this blue microservice is consuming that event, right? So they are loosely coupled microservice. They are not dependent microservice. So the loosely coupled microservice is the architect which supports a loosely coupled microservice is a event-driven architecture, right? So this is the way how we can do our create a event-driven architecture. And so how we can the Ethereum works in this event-driven architecture, you can see. So this is blue is the Ethereum layer. Product is a microservice, product microservice, and Kafka broker is a Kafka cluster, right? So when we execute the test cases and we create a product, so by REST API we create a product because this is a micro service, and it responds back. So it responds 201 response code, and that product is created. Then what this service do? This microservice create a event, Kafka event, to a Kafka broker, and meanwhile that this Ethereum layer is consuming that Kafka topic. So it is consuming that Kafka topic, and then the event which is created by this product microservice, it will consume that, and then it will validate whether that Kafka event is created properly or not. So this is the way how this framework works. So now we will discuss what is a Apache Kafka. So Kafka is a community distributed event string platform. So it is a event streaming platform, and main purpose is that you can see in this image that the number of producer produce the event to a Kafka cluster, and then consumer are consuming that topic, and they just consuming that event message. So this all the architecture which is given by a Kafka. The producer produce the message to a topic, particular Kafka topic, and the consumer consuming the particular from a particular Kafka topic. So this is a Kafka. And how Kafka message validate works. So we will see in this slide. So you can see at the start, start there is a start arrow where a event is created by a any microservices, and then it goes to a Kafka cluster, and then the consumer consumer consume that event from a Kafka topic. So here the Ethereum is consuming that topic, and if it get that topic, then it goes to uh, uh, ahead to pass the message. If it is not, then it will iterate 5 times. So it is a configuration value. You can configure this value to rise or decrease the value. So by default repeats 5 times if it does not get that Kafka event to particular Kafka topic. So it got that event, then it passed the message with message type. So we will see what are the message type in upcoming slides. So here it passed the message with a message type, then it store the actual response, store the message by a event name. So the event name, it stored the message by a event name, then it check whether the id the id is present in that event or not. If it is not present, then again it goes and again it start consuming the particular it consuming the particular topic, and just check whether that event is coming or not. If it is present a unique that id, then it's goes here where it is comparison actual JSON with a comma separated JSON. So this is the expected JSON we need to give, that this type of message will come from a Kafka topic, and this is the actual JSON which comes when we consuming that particular Kafka topic, and then we are able to validate the Kafka message, right? So this is the way how these frameworks validate the Kafka event message. And then this how to validate Kafka event message with the Ethereum. So validate the Kafka event message. You can you can validate the Kafka event message. Consume the Kafka message from a Kafka topic. Obviously, you need to consume that Kafka topic, and you need to produce if you need to produce any message to Kafka topic, you can do by this framework, and you can validate the event message for JSON message type. So currently it is supporting all the different message type, but now predefined message type is available for a JSON and protobuf. So if your message type is JSON, you are ready and you can just start this framework, and you are able to validate your Kafka event message and validate the Kafka event message for a protobuf message type. this framework is easily integrated, means this Kafka validation is easily integrated with the REST API DB and Kafka validation. So in a same test case, you can write your test REST API, you can write your DB, and you can write your Kafka validation in a single test, in a single Excel sheet. Message aggregation. So this supports also a message aggregation, aggregate multiple messages. So now we will talk about a setup. So how we can configure this framework or create this framework. So to configure this framework, you need to create a Java project, a Maven project, and you need to update two dependency. First is Ethereum dependency, and second is TestNG. So for Ethereum test dependency, you just get all the Kafka code, how you can configure, how you can validate by using that code. By using TestNG, you are able to run your test cases, and this is a proto to Pojo plugin. So if you are your message type is protobuf, so you can use this plugin. If you are your message type is JSON type, so you do not need to use this plugin. Yes, for next is a Surefire plugin. So to running uh, any TestNG XML file, you can have to integrate this plugin in form.xml, and this is a Cucumber report plugin. So by using this plugin, the Cucumber report is generated by this framework. Second is how we can create test cases or Excel file. So we will discuss. I will show you when I show the code. So how we can create this. So currently I will skip. So there are just for a brief introduction of this. There are multiple columns you can see here, and there is a type. So here is a Kafka type. So here REST is a I'm creating a product here, and by using Kafka type, I'm validating the Kafka message. And resources is a proto. So this is my resource is a proto, and message type is a protobuf type. So I will show you in upcoming means when I show you the code, then I will show you this how we can create and what are the different columns and values for this uh, create product event Kafka event test cases. Second is step 3, that we need to create a Kafka executor plan. So to to run this framework, we need to create a YAML file, which is a workflow proto file, and there are multiple configuration you have to give. So this is all you can download this from our GitHub, and this is all the configuration you will get. So for a multiple parallel execution is given here. If you have to change your report title, so you can change a report title here. If you want to run your test scripts in different environment, so you can change your environment here, or you can create multiple environment here. Then where you have to store your Cucumber report, you can give here, and where all the contract JSON file and feature file is created. So when we run the uh, this framework, then some JSON file and some feature file is automatically created by this framework. So where we have to store this, so we have to give the path here, and then the Excel name. So the test script where you have write all the steps, you can give that name here. And if you are using any APIs, then you can give that API service. So in previous slide, you can see the resources is a API service. So I'm using a REST API to create a product. So I give a resources API. So it will take the endpoint from here. This is the base URL, and then it will execute this. So this API service is same under a resources. And next is if we are using a protobuf, so there is a proto file which is provided by a contract team or other team, maybe dev team or other team, and you have to add this under a main folder. So this file is given by contract team and dev team. So this is just a contract that this type of protobuf message we are creating when we create that Kafka event. Okay, so this message we have to create under a Java main folder, and then we have to create a message type properties. So if we are using a protobuf message type, then we have to create 5.a. So here this is a product created. So product created is a event name. So in a Excel, you can see that event. This is a Kafka. So this is a event name. So this event name is same. i- This event name. Okay. So here, if I'm talking about a protobuf message type, so this is the package name, and this is the class, and this is a JSON path, which is a ID. So how will I get this? I will get from here the proto file which is provided by a contract team. You can see here this is a package name, and this is a class message. So this is a message here. Okay, and this is a unique ID, and but this is a JSON path. So the product ID is a JSON path here. Okay, if you are using a JSON message type, then you have to create a JSON message type properties, and you need to store under resource folder. Same way, if you are using a protobuf message type, then you need to create a proto message type dot properties, and you need to create a resource folder here. Okay, so again, order created is a event name, and order number is a JSON path. Same way, and then we have to create topic properties, because if any Kafka event is produced, so it is stored to a particular topic. So we have to give a topic name here. So this is a topic dot property which you have to put under resources folder. Again, this is a event name which I have shown you earlier, and this is a topic name. So what is the topic name you put here, and this is the event name here. So this some configuration you need to do, and then there is other producer properties and consumer properties. So you have to create a new producer proto dot properties. So proto is a resource which I have shown here. So this is a resource. So this should be the same with this. So producer proto dot properties, and you have to put under resource folder. So this is the configuration which is used by a Kafka. So you can see that there is a key serialization and value, and this the string serialization, byte array serialization when we are producing. And if we have to also put a consumer property, so this is a consumer proto dot property is if I'm using a resource as a proto, and again I have to put this under resource folder. And again here you can say this is a serialization, and this is a deserialization. Okay, deserializer. So these are all the Kafka configuration which is provided by a Kafka. So we just need to create these properties with this name, with a resource name which are we are using. If we are using JSON, then the producer JSON dot properties name should, and then this is a custom message. Okay, so to build any consumer message, we have to pass that message into JSON. So in one of slide I show you that we are comparing actual JSON with a comma separated JSON. So to pass the to to pass our Kafka event message to a JSON. So these are JSON. So these are also predefined. You will get in the framework this. So just this is a topic name. This is our here we are Kafka header partition. So these are the some Kafka headers value we are getting here, and this is the key value for the consumer record. So this is only a consuming message type. So this is one of the Java file you have to create it, and you have to just modify according your message type. Okay, And again, this is a Java class for a Kafka test plan executor. So in this class, you just need to give that YAML file which we have discussed earlier, that that name of YAML file, and at the rate test annotation shows that we are going to run this method by a test. Okay, so we need to just create a Kafka test plan executor file to run our test scripts. And this is our testng.xml. Okay, and in this testng.xml, this is a event executor.xml. So we have to give a where we have created our that at the rate test annotation method. So this is the file which we have created, and we have give this class file on here to run to execute through our testng.xml. Okay, so how we can run our test cases here? So this is to there is a simple command mvn clean install or mvn clean test. By using this command, you can run your test script, and then after execution, you can see it created a feature files, it created JSON files, and also it created a reports here. So the path which you have given on YAML file, under that part it will create that overview feature.html. Okay, so to run this, we have to just click a mvn clean install command. Okay, so these are the some folder structure here. So you can see the two message type I was talking, that JSON type and protobuf type. So this is a message type which we put under test here. Okay, and this is a Java file. This is the file which we have to run. The test case is run through this Java file, and this is YAML file. So this is a workflow file which we have created, and to run our Excel means test scripts, and this is the test scripts which are Excel files, and these are created JSON file. So when we run this, then automatically a feature file and JSON file is created by this framework. So these are the feature file, and these are the JSON file you can see here, and this is the testng XML file which we talked in last slide. Okay, so this is the structure here. Now we can see a reporting part here. So reporting is good with a good UI feel, and it supports a BDD Cucumber structure. So you can see there is a feature. So there I have run for two features. So order created event workflow and post message event workflow. So the feature is display here. So this is a dashboard of here. What are the steps are has been passed? It shown here, and what are the scenarios run under these two features? It is displayed. So this is a dashboard here. Then this is a workflow message. So you can see there is a detail message where when you click on this hyperlink, then uh, uh, this page will open, and you can see the feature name here, and the what duration it take to execute. All the information comes here, and then this is a detail reports, and this you can see this is the scenario name, and this is step info. So in our Excel, we have to give our some test step info. So that step info display here. This is our in this Excel, we are creating some variable. So that variables come here under as a product ID. Okay, and then this is at fourth step, it is creating a product by using this API. So this is the endpoint, uh, and it is creating our product. So it is display here, and then at step 5, what is this, that the product is created. Now we are now response backs by that microservice, which I shown you in some of previous slide, that that microservice create a product and then it give the response back. So here we are validating that response, that okay, that product is created and this is the response come that from that microservices. And this is the Kafka validation part. So the message type is a protobuf, and this is a proto, and this is the expected and actual JSON display here. Okay, so at the last we are validating our Kafka event message here. So for our last step for our Kafka event message validation, this is the detail view. When we click on this expected and actual response, then you can see the expected and actual response display here, and we can see okay, all the items are matching correctly, and it is showing here that okay, this is the product created, and this is the product ID, and this is the proto buff message type here. Then if any test case is failed, then this is the thing which we get. So you can see that okay, that does not match here, and this is the failure. So we can see okay, what are the value which is not matching with the expected value. So this is the report part, and now we can see that this framework is also integrated with the Jenkins. So so today most of the frameworks are able to integrate with Jenkins. So I have created one of a pipeline where I have integrated this framework as Jenkins. So what does mean that we can validate our Kafka event message through Ethereum, and that Ethereum is able to integrate with our Jenkins and we can use this framework as a CI and CD. So this is the job name, and when I click on Cucumber report, so all the reports has been displayed here. Okay, and this is my post message event. If I click here, so you can see that this is what we are talking here. So this is the way how we can integrate our this framework with our Jenkins. Okay, so now demo time is come. So for our demo scenario, I have created two scenarios. So first scenario in which I am showing how we can validate our Kafka event, which message type is JSON message type. And in other scenario, I'm going to show you how we can validate Kafka event message, which message type is protobuf message type. In one of scenario, we are creating a Kafka message by using a Kafka producer, and in another scenario we are creating a product, then that product microservice creating a Kafka event, then we are validating that Kafka event. So these two scenario I'm going to show you. So let me open my IntelliJ here,
Hi,
and
Chirag. It looks like we'll be nearing the Q&A session soon. Would you be able to do the demo within the next 5 minutes?
yeah, so just I'm doing here. Okay,
Sounds good. Thank you, Chirag.
thank you. So you can see here that this is one of the test cases, and here the test case name is we have put here test names, and this is the type is a Kafka type because we are using a Kafka type, and resource is a JSON here. So because we are using a JSON, so we put a JSON resource here. So same way that JSON resource comes here, you can see that JSON message type here. So this should be the same. So this is my that event name. So you can see the event name here, and this is a JSON path for my order number. Okay, so this my order number is here. So in this, what I'm doing, I'm creating our Kafka event by using a producer here, and this message type is a JSON type here. So you can see that JSON message type is here under test Java. So you can see the JSON types here. And if I go here, so here it is reading a JSON message type properties. This is JSON message type properties here, and at the top these are JSON types. So these two, JSON type and protobuf, is a predefined uh, available in the framework here, and this is same for a YAML file. And let me run this, and so that we will see a demo. For running this, I have to just go to a Maven, and this clean and install I have to do here. So currently it is compiling the code. Okay. So meanwhile, this code is running. So I discuss four new things here. So this is the topic properties which we discussed here. That this is the for my this order created, this is the event name, and this is the topic name here. And this is a producer JSON property. So my resources are JSON. So these are, let me close this. So these are producer JSON properties either here, and this is consumer JSON properties. So I'm talking a message type for a JSON. So this is a YAML file. This is the YAML file, and this is my uh, create order event Excel. So this Excel put here, and this here I'm giving here this, and this is a message type. So for a JSON message type, we already discussed this, and this protobuf message type. So this is a event name, and this is the same value which we had discussed. And what is a proto file? So proto file put under test. So you can see a proto file, and this proto file is given by the contact team or given by the dev team. Okay. So this is that package name, and this is the message for the product and for the customer. If again I go with that file here, proto message type, so you can see this both here, and this is our JSON path for a product ID, and this is a consumer ID. So this much configuration you need to do, and just you need to just start by clicking Maven clean install or clean test. So this way it will run, and now it is generating the report here. So let me show the report to you. And so reports comes and target is Ethereum, and this is the feature file. Let me open this to a browser, and you can see the report here. Okay, so this is a product report. So let me show the steps here quickly, because we are out of running time. So this is the same which we have discussed here. There's this creating a product API action. This is the which I already discussed you, and this is the actual response which by which we are creating our product, and this is the response which we get from the product API. This is the expected response, and this is the actual response. And here this is also a validation part for that expected response, and this is a actual response. So this is part for that Kafka validation. So this is Kafka event which is produced by that product API, and this is the Kafka event which we consume from that particular topic that is produced by this product API. Okay, so this is the report part, and let me go with the slides. And this the some URL, so you can go for tutorial. You can go with this URL, and if you want to configure this framework, you just go to this GitHub repository, and this is the form URL. So for I'm ready for a questions here.
All right, fantastic. And just like that, it was just exactly 5 minutes. So that was very nicely done. Thank you. So yes, let's move on to the Q&A session, which will also be 5 minutes. The first question here is, can you please provide insight on Kafka? It's like API testing or log management?
So basically for Kafka is log management. It is not. It is a message distributor platform. Now it is used as a event distributor platform, where we can where we can produce multiple events. So it supports a trillion event in a day. And where suppose there is a credit card company where a number of events is created in a second. So they are using this type of technology where a multiple events is coming, and they have to produce a event in a central cluster, and then another API is consuming that event. So this is the Kafka.
Okay, nice. The next question here is, can we validate event messages other than JSON formats? And then the follow-up question is, what are all the message format can be validated using Apache Kafka? Sorry, Chirag, I cut you off over there. Please continue.
Yeah. So yeah, we can do other Kafka message type. So basically JSON message type and protobuf message types are most popular. So we give a predefined definition of that in our code. So we already write the just parsing the JSON event message to a Kafka event message to a JSON message, and there are multiple message types. So you just need to write that parts code here with in this framework, and then you are able to good to use other message type also.
Yes, and earlier Chirag did say yes to the first question, which was, can we validate event messages other than JSON? So just to let the audiences know, he did say yes. All right. So the next question here is, we will get trillions of messages in a day. What would be the primary key constraint to identify the expected event message? In simple terms, based on what JSON key, you can say this is expected event message which sent from producer.
Okay, so so for that, when any message is coming to a Kafka cluster, so it's come with a header. So headers gives a unique identifier, and from if there is no unique key available in that Kafka event message, so you can go to a Kafka header. So there is a unique Kafka event message, unique key is available. So by using that unique key, you are able to identify that message uniquely, and then you just validate that message.
Nice. The next question here is, why do we need to validate the message in Apache Kafka? We can directly validate the event messages in DB such as Cassandra, HBase, or any relational DB, right? Why we need this use case in test automation?
Okay, so basically, when a Kafka message is created and it pushed to a Kafka cluster, then there are some consumer, they are consuming that message, and then they store that message to a DB. But in this point, you are testing in middle way. You are testing before they are putting that message to a DB. You are validating all the Kafka event. You are not validating that okay, the consumer read that message, then they put into a DB. You are validating at a midway where you are consuming that message from a Kafka cluster, and you are validating whether that Kafka event is created or successfully or not.
Okay. The next question here is, you mentioned about the event message will be processed by Apache Kafka. What does it mean? For example, processing event messages?
So basically, Kafka is not means a microservice is create a Kafka event to a cluster, which is known as a producer, and thus other microservice is consuming that Kafka cluster or particular Kafka topic is a consumer. Okay, so Kafka is just nothing. It is just receiving a message, and it is just giving a message. And why we are using, because a number of messages coming together, by using Kafka we are able to get all those messages in a single time.
All right. And the next question here is there no event topic? Sorry, if there is no event topic, how do you process the event message?
So basically, event topic is give a topic dot properties. So there is a event name which we have mentioned under event column, and you can see there is a topic dot properties which I show you, and that properties we have given a topic name.
All right, fantastic. And that concludes the Q&A session. Thank you, Chirag, for answering all of these questions. And now we shall move the session to, you've guessed it, our quiz, which will be hosted by our quiz master, Manish. Manish, I invite you to host the quiz.
Sorry, I was on mute. Thank you, Daniel. And thank you, Chirag, for insightful of this Kafka and integration. So
Thank you.
everyone, yeah.
Thank you, Manish.
So let me start quiz now. Okay, guys. So hope my screen is visible and you can see the leaderboard from the past. Okay, so here you go with the first question. Okay, cool. Next question. I believe audience who are listening to you carefully, they're giving 100%. Okay. Okay, there's confusion, I guess. Let's see what is the correct answer. All of the above. Cool. So, guys, very last question for this session. Hope you all ready. Here you go. Okay. People have a doubt. Let's see. All of the above. And here is the leaderboard, guys. Okay, since no change from last. Thanks everyone. Over to you, Daniel.
All right, thank you so much, Manish. And that concludes our quiz session. Chirag, do you have any final words before we move on to the next session, to conclude your session?
Yeah, so thanks guys for attending this session, and thanks Daniel for giving me a chance to being in this QA community. So thank you very much.
Thank you so much, Chirag Singh, for being our speaker as well. All right. Okay. Now, for everyone else here that's watching, just some gentle reminders. Please, if you are watching from a mobile device, do switch on over to your desktop version to get the best user experience from our Zoom events. And I will now be ending the webinar, and all of you will be teleported back to the lobby, and so that you can join the next session. If you've been here for a while now, then you know the drill already. All right, everyone. See you guys in the next session. And thank you again to Chirag Singh. Thank you.
Bye.